Hello everyone, my name is Sanvi Kapoor and today I'm going to be teaching you about Newton's three laws through a couple demonstrations. So let's get right into it. Newton's first law states that an object will remain at rest or in uniform motion unless acted upon by an external force. This characteristic is more specifically described as the state of inertia, in which an object initially at motion would want to stay at rest as they begin to have force exerted on them. Any force of motion resulting in inertia would involve acceleration. In simple terms, an object at rest will resist motion and an object in motion will resist acceleration. Here's my first demonstration of inertia. While I'm stopping at a red light, the velocity of the car decelerates until it reaches a final velocity of 0. It is clear that the stop impacts the passengers of the car because they were traveling at a constant velocity before having to stop. The principle of inertia is the reason why a slight jerk is felt to the passengers because their body was used to the constant motion and chose to resist the change, which causes them to move forward a bit. Now moving on to demonstration number 2. When you are running or sprinting a specific distance, you will never just completely stop at the finish line and will instead continue running a short distance after it. This is another example of inertia, as the runner's body doesn't abruptly stop since they feel as if they are still in motion even after finishing the run. A runner is probably running at the fastest velocity by the end of their distance as they accelerate throughout, which makes it difficult to simply stop at the end. When the runner finishes the race, instead of stopping, they decelerate so they don't fall over and hurt themselves from all the force that they were carrying. Newton's second law states that the net force and acceleration are directly proportional to each other. This means that if the amount of force doubles, then the acceleration will too. But mass is inversely proportional to acceleration, which means that if you doubled the mass of an object, then the acceleration would be half. Newton also discovered that the more a mass, the more force required to be exerted for it to move. Object A, my brother, kicks a ball, Object B, with a different amount of force for each trial. In trial 1, he kicks with half force and it leads the ball to travel with moderate acceleration in the air. In trial 2, he kicks with full force, which clearly creates a greater acceleration from the ground than trial 1. This proves Newton's theory that force and acceleration are directly proportional because all the variables are the same in each trial besides those two, since they increase and decrease together. Over here, we have one stool and two stools, and we test the difference of resulting acceleration between each trial. Pushing the one stool is clearly easier than pushing it with one more on top because the second trial has a larger mass than the first. This proves Newton's theory of a second law that acceleration and mass are inversely proportional. When we added more mass to the object acted upon, it created a lower acceleration than the object with less mass, and if we remove mass from the object acted upon, it creates a higher acceleration. Newton's third law states that for every external force that acts on an object, there is a force of equal magnitude but in the opposite direction, which acts back in the object which exerted the external force. In simple terms, for every action, there is an equal reaction that will act in the opposite direction and act back. We throw a small ball against a wall from different distances away. As you can see, with each throw getting further away from the wall, the ball makes its way back to the ground around the same area on the floor from where it was thrown from. This is a prime example of equal force creating equal reaction. When the ball hits the wall with force, the wall replicates the same quantity of force back into the ball, which makes it travel to the same distance back from where it came from. In our last example, my brother and I are standing side by side in a straight line, and I slightly push him on the side like a pendulum. When I do this to him, he gets pushed in the direction that I applied the force, while I slightly get pushed in the opposite direction that I exerted the force. This represents an occurrence of object A, myself, exerting force on object B, my brother, in which object B exerts the same magnitude of force back to object A in the opposite direction, and we alternate and the same thing occurs for the both of us. Thank you so much for watching. My brother and I hope you learned a thing or two or three about Newton's three laws.